basics of sound. We will finish up with that today, and then move on to talk about light. Again, two types of energy with some similarities, but also with some differences. So, light waves. So, what do we call the type of wave that sound travels through? Yusuf?
Sound wave.
Well, we had another word for it. If you remember my slinky. Did No. Compressional waves. Okay? Compressional waves, where molecules squeeze together and then expand. Okay? Light, however, moves as a different type of wave. Okay, though?
Okay. When you get us to
Hold that. So, now, a transverse wave moves. Oh. Sorry. A transverse wave moves, so a compressional wave moves, parallel to the direction that it's moving. A transverse wave, okay, moves up and down, perpendicular to the direction it's traveling. So again, when you see this little wave that we send across, right? Now, again, does the metal coils move from here to Michaela and back?
No.
No. Just as the wave travels, the spring moves perpendicular to the direction it's traveling, and then it relaxes, and that moves along the length of the spring. Okay? Hold this tighter. So, all right. Don't hold it still.
We tried to hold it still.
All right, so we have repeat it now. You could, if I speed up, what happens to the number of waves in there? It increases. Or I can make a small wave, or I can make a larger wave. All right, so let's talk about those things. Good job, Michaela.
Oh.
Sorry.
But
All
could
right.
it actually hit her in the face?
Did it?
No, could it?
Not if she held it still. All right, so in a wave, the particles are moving perpendicular to the direction that the direction of the wave is traveling. The matter itself doesn't move from one end of that spring to another. When we talk about waves, we use some terms, and they're not too difficult to figure out. I'm sure you can figure out what these words mean. So this represents one of these transverse waves. Okay? We could talk about a few aspects of it. Okay? We could talk about the crest of a wave. Crests are the high points of the wave. Okay? So this is a crest. This is another crest. This is another one.
We're going at like the light speed of
Light speed times 2. A turtle?
Yeah.
Faster?
We're on
All right, anyway, a trough is, what do you think? The lowest point. This is a trough of one of the waves. What do you think wavelength would be, Matthew?
The length between the crest and the ball.
Close, but not quite. It's the distance between two crests or between two troughs. So from here to here would be one wavelength. And it's a measurement, it's a distance. From the trough of one to the next trough, or the crest of one to the next. A couple other words we use. The normal is the imaginary line that divides a transverse wave down the middle. And finally, amplitude. What do you think amplitude is? Jax?
the measure of how like the frequency of it.
Not quite frequency. You said?
Measure of the intensity of
It's related to that. It's the height. It's the distance from the normal to the top of the crest or to the bottom of a trough. That's amplitude.
If a crest got tired, does a trough get lower?
Yes. If we think in terms of sound, if you increase the amplitude of a sound wave, what changes about it? I want to take a guess. Actual sound you can hear, a sound you can hear. If the amplitude increases, Michaela?
Lower.
No. Matthew?
The pitch changes?
No. Pitch stays the same.
I keep forgetting the question.
There's a smaller wavelength.
Think about amplitude. Where have you maybe heard something similar?
Oh.
Amplitude.
An amp, like a guitar amp, an amplifier. What does it do?
It makes it louder.
Yes. Increasing the amplitude makes the sound louder. What about increasing the wavelength? No? Yes.
Makes it softer.
No?
Like a bass.
It changes the
Tone.
pitch.
Pitch.
A longer wavelength is a lower pitch. A shorter wavelength is a higher pitch sound. Okay. I know you have the opposite. You have the words already. Go ahead and draw your line in. We have the crest of the wave, a trough. So you have to draw your wave in so it hits the correct points. The normal, amplitude, wavelength, amplitude.
Is that good?
Yep.
Yeah. You just got that weed.
All right. Now let's talk about light energy. So we talked a little bit about sound. Light is, again, a type of energy. It's not matter, but energy. Okay? And light is produced by electrons that are excited. If you remember when we talked about chemistry, electrons are where in an atom?
On the outside?
On the outside at various what?
I was gonna say.
Shells, or energy, or orbitals. Light can be produced when an electron is excited and moved up to a higher energy level, and then when it returns back to its original stable level, it can release a particle called a photon, a sort of particle of light. Okay? And that's what light is made of, little bundles of energy called photons. And we probably are not going to get into it, but if you ever read about quantum physics, and there's a paradox in that sometimes light behaves as particles, as little packets of light, and other times behaves as a wave. Okay? And light travels as both. Okay? It behaves as a wave and a particle. So light travels through the waves we just talked about, a transverse wave. And that's different than sound waves. Sound needs a medium to travel in, molecules, matter to travel through. Light does not. Can light travel through space?
Yes.
Yeah, that's why we can see the sun and stars and the moon. It does not require any molecules, light from the sun or light from the moon, to reach us.
Wait, so Mr. Kuros, if something like Mars was to explode, you wouldn't hear it?
No. There'd be no way for that sound to travel and reach us.
Wow, so we couldn't really see it?
Yeah.
That's crazy.
Me and like 6 people were having an argument during lunch. What would happen if the sun, how long would it take us to die if the sun exploded right now?
It would happen fairly quickly. I'm trying to think of the time it takes light to travel.
8 minutes.
8 minutes?
Yep.
So after 8 minutes, the sun's energy would have reached us, okay? And then the sun would be whatever, black or whatever, depending on what happened. And then after that, we would die pretty quickly. Sound travels in compressional waves, light travels in transverse waves. It's another difference between sound.
Like then what dies like this? If there's no sun, what?
I mean, if there's no sun, the temperature of the earth would drop.
Oh yeah,
You
of
know,
course.
drastically. And also, what requires sunlight? Yeah, plants, photosynthesis. That's the biggest problem. All right, so
Oh wait.
light has several properties that we can think about. Okay? It has speed, frequency, amplitude, and wavelength. These are all properties of light that could be measured. And sound has the same properties as well.
So, if E equals mc squared, you need infinite mass to go to the speed of light, right?
Yes.
So, light doesn't have mass?
What's that? No, because it's a form of energy.
Okay, so it's just like an exception?
No, because E equals mc squared tells us that energy and mass are equivalent. Energy equals mass. And they can be converted back and forth. A nuclear reaction happens when small amounts of mass are converted into huge amounts of energy. And that's what E equals mc squared tells us. All right, so light has both electrical and magnetic properties, and therefore it is a type of electromagnetic radiation. That's the term we use for light, but also all other types of electromagnetic radiation are just like light, but they're different frequencies. So radio waves, for example, are basically the same thing as light, but they're a much lower frequency. If we look here at the electromagnetic spectrum, all of these types of energy are electromagnetic radiation. We sort of put them into categories based on what they do and how we use them, but they're really all the same thing. So at the lowest end, the longest wavelengths, we have things like radio waves, microwaves. As the wavelength increases, we have infrared light, which is basically heat. Then here we have visible light. Visible light is a small section of the electromagnetic spectrum, but it's basically what our eyes are tuned to. Our eyes are tuned to sense electromagnetic radiation in this narrow band of the spectrum.
So,
Some animals can see slightly above and slightly below the visible light that we can see. For example, like some insects can see beyond they can see ultraviolet light. And some flowers actually have markings that are outside of the color spectrum that we can see, but that insects can see that they're attracted to. So beyond visible light, we have ultraviolet light. As we move up in frequency and down in wavelength, because the two are related, we have X-rays and eventually gamma rays. But they're all basically the same stuff.
what's the last one?
What's that?
The orbiter right there?
Oh, that's just showing, I think it's just showing gamma rays, which are emitted from stars and so forth. All right, so if we look at this, frequency is increasing as we go across. So think about frequency. Let's just start carrying. Think about frequency is how quickly the waves are coming. How is frequency related to wavelength? If we decrease the wavelength, what do we do to the frequency? What's that? Nope. Because if the wavelength is shorter between each wave, how frequently will they be arriving?
No, faster.
So frequency is increasing while wavelength decreases. Also, as we move up the electromagnetic spectrum, these various types of energy have a greater ability to penetrate into objects.
Wait, what's the positive direction?
Direction on this diagram.
Oh.
So as we go, radio waves do not have a very good ability to penetrate into things. That's why, have you ever been trying to put on a radio station on here, and when you stand near the antenna, you can get the station and you walk away and you can't? Okay, because that those radio waves are reflecting off of you to the antenna of your radio station. Or if you go under a bridge sometimes, the radio station goes out a little bit. Because those radio waves can't penetrate through the surfaces that the roads are made out of. If we move up, think about X-rays. Are X-rays able to penetrate into our body?
Yes.
Yeah, that's how they're used to make an image of our bones. Things like gamma rays can penetrate and they can be very damaging to a person because they can penetrate into our skin and damage our cells.
Oh, is that why if you go too close to the sun, you like?
That's one of the reasons. Oh, the other thing, if you ever had an X-ray done. Anyone had an X-ray recently? An X-ray of what? Okay, so what do they put on the rest of your body?
It was like it wasn't a magnet, it was like something that.
A big, like, heavy blanket, right? What is in there? You know? Lead. Why do they put that on you? Nicholas?
So it can't. Oh no, so it doesn't like go straight through your body, so it'll just go through like the light. Like,
Yeah, because X-rays can damage our cells, they only want to expose as little of you to the X-ray as possible. So that's why they step out of the room. You know, the X-ray technicians, they'll stand there with you while they take the X-ray. They move out of the room, they press the button outside. Or if you go to the dentist, you know, they put the thing zoomed in on your teeth, then they walk out and press the button. That's so they don't expose themselves to X-rays because they can penetrate into your body and they can cause damage over the long term if you're repeatedly exposed to them. Now, you know, 10 or 20 or 30 X-rays over your course of your lifetime is not going to do much damage. But for a dentist who's doing this all day, every day, that those effects could lead up. In fact, the first people to discover radiation, most of them died of cancer because they didn't know about the negative effects of this radiation. Nicholas?
with the microwave, is that like somewhat to do with why microwave sometimes makes harder than not?
No, it has to do with, I mean, they have long ways that they accelerate water molecules heating up a substance.
Why is there nuclear sound in there?
What's that? Because nuclear energy releases gamma rays.
Okay, what are gamma rays?
Gamma rays are just a form of electromagnetic radiation that has a large amount of energy and has the ability to penetrate into objects deeply.
I have a question.
Matthew?
How can gamma rays like and radiation give you radiation sickness? You know?
Radiation sickness is the result of radiation damaging cells in your body. So those radiation, those high energy sources can actually break down your DNA and your nucleus, leading to problems.
So I heard that if you stand in front of a microwave while it's on for like a really long time, it can like lead to cancer.
No, I don't believe so, because it's shielded. And microwaves, when you look at our list, don't really have a great ability to penetrate through substances. So again, here's the same diagram. It's just reversed, where we have radio waves on the right, long wavelength, getting to shorter wavelengths down here. And again, as wavelength gets smaller, frequency increases. David?
What about like TVs, laptops, and cell phones? Don't those emit some type of radiation?
Not a whole lot.
Okay,
No, I mean, small amounts. I mean, how do cell phones work, and what type of radiation?
radio.
Radio waves, yeah. So they're low power waves. But people have hypothesized that exposure over the long term repeatedly could cause, but there's been no positive link actually in scientific research.
Yeah, like they say that if you keep your phone in your pocket too long, it could actually lead to breaking down of the front. So not
I haven't heard that. Nicholas?
Is that also why if you have like too much noise or damage your ears, so there's radio waves?
No, that's related more to the physical effects of loud noises, high amplitude, damaging your eardrum physically. All right, now, as you probably know, what are the colors of the spectrum? Can you guys tell us? What? Yes, how do you remember that? Roy G. Biv. You remember like a person's name, Roy G. middle initial Biv. Those are the colors of the spectrum. What we think of as white light, the light coming from these lights, for example, or generally light from the sun, is actually composed of all of the colors of the visible spectrum. Red, orange, yellow, green, blue, indigo, and violet. Roy G. Biv. They're also the colors of
The rainbow.
the rainbow, because a rainbow is a refracted light which gets spread from white light into its component colors. And so you see visible light falls in the center of the spectrum here. Okay? And red has the lowest frequency. Violet has the highest frequency, and the other colors are sort of in between.
Oh, that's right. So smart. Infrared, ultraviolet.
Exactly. Where on the spectrum is infrared? Just below red. Ultraviolet is just beyond violet. And those are just two other types of electromagnetic radiation. Matthew?
So is that why like thermometers are red?
No. They're filled with alcohol, which is currently red and
I
dye.
remember there's this little game that the MIT lab made. It was called a slow speed of light, and if you it's when you collect orbs that make you travel faster, or no, it slows down light, and then if you move fast enough, you can get like red shifting and blue shifting.
Oh, yeah. Yeah, and as objects in the universe move either closer or to away from you, their color of them changes. That's what red shift and blue shift is. Okay, when something comes towards you, it's also responsible for the Doppler effect. When you hear a car go whizzing by you, what kind of sound does it make? Right? Or if you ever heard like a siren coming towards you and moving past you, the pitch of it seems to change. Okay? That's basically red shift and blue shift. As it's coming towards you, the waves get closer together because it's being pushed forward, and so the frequency increases. As it goes by you, those waves get stretched out and the frequency decreases. It's also how scientists can tell if a star is moving away, or objects distant in the universe are moving closer to us or away from us, based on how the color of that light changes. Okay, this is a, what do we call this? A prism. A prism takes light and scatters it. It takes white light coming in, okay, and scatters it into its component colors. It's the same principle by which a rainbow is formed. And again, red, orange, yellow, green, blue, indigo, violet. And just over here would be infrared, just over here would be ultraviolet, if we can see them.
I remember.
Yes?
They made this thing in Canada or London that bends, it's a sheet, but it bends light around you and like almost mirrors everything that's behind you, so you can like blend it really well.
Cool. All right. Trivia question. Which band, which classic rock band produced an album which, you don't even know my question yet, do you, Nicholas?
No,
Which featured a prism scattering light. What is the band and what is the name of the album? Nicholas?
I know, Pink Floyd.
Pink Floyd, good, that's the first part.
Bingo.
What's the name of the album by Pink Floyd that features a prism? Matthew?
Scattered light.
No. It does have an astronomical term in it.
Pink Floyd.
No, that's the name of the band. It's not the name of the album.
Name the album.
All right, go home and ask your parents.
I have a word in there.
What?
Is it possibly ultraviolet?
Nope. All right.
What is it?
I'm not telling you. Go figure it out at home.
Spectrum?
There's this new website. It's called Google. You can probably figure it out. All right. So
Bing is better.
really,
Yeah.
I don't like Bing as much.
Bing gives
Bing has got better pictures in the
Bing
background.
gives me free stuff for using. Yeah, you can
Okay.
use me like a.
I know I got a whole bunch of Xbox points because I used Bing and got all
So
the
do I.
rewards. All right. Anyway, yes. White light comes into a prism, forming which colors?
Red,
Red, orange, yellow, green, blue, purple.
Red through violet. Red is the longest wavelength. Violet is the shortest wavelength. Yes, yes.
Why don't some people include indigo in their
I don't know, because nobody really knows what color indigo is. Purplish. Well, how's it different from violet? I don't know. It's in between blue and. Yeah. All right. All right. So, when light shines on an object, a few things can happen to it. Okay. It can transmit that light, can absorb that light, or it can reflect it. Okay? Transmitted means light just passes through. What does absorb mean?
Like,
Stop.
gets it.
Gathers it in?
Yes.
It takes it in? What does reflected mean? Bounces off, right. So as light hits this table back here, pretty much what's it doing to all the light?
Reflecting.
Absorbing.
No. Yes. Why is it turning it on?
Because
As she always
black
is.
doesn't really reflect light.
If this was reflecting most of the light, what would it look like?
White.
It would be white.
So that's reflecting.
That cabinet over here, the light that hits it is
Reflecting.
all reflected, which goes into your eyeballs, and that's why it looks white. This looks black because
And
the
what about
material
the
it's
brown?
made out of absorbs all of the light.
And the brown is in the middle.
Wait, I'm confused that transmits
What's that?
is brown.
No.
Wait, I don't.
What would be something that transmits light? Matthew? The windows. Glass allows light to be transmitted through.
Wait, I don't think it's transparent.
White light is hitting this table, right?
Yeah.
Yes, light from there is hitting this table. It's absorbing it, and so when you look at it, is any of the light reaching your eyes?
Well,
It's
kind
being
of
absorbed, so no, and it looks black. Black is the absence of light.
Maybe when it's lighter.
What happens when light hits my shirt or Matthew's shirt?
It
Is it being,
no, it absorbs everything but the green.
yes, our shirt, Ryan and mine and Nicholas's shirt, Matthew. Our shirts are absorbing most colors of the spectrum, but they're reflecting one color, green. And that green is reaching your eyeballs right now, and so our shirts appear green.
What makes it dark green and light green?
Different amounts of absorption or reflection of those molecules. That's what dyes and pigments are. They are molecules you can add to clothing or to an object that will allow it to absorb different wavelengths of light.
Wait, how come it only reflects like green?
Because of those molecules. These molecules absorb certain colors and reflect certain colors. Kimberly?
This is kind of like, it's kind of long. But my question is with the albino animals, I know they lost the pigment, but why is light transmitted through their eyeballs not?
Through their eyeballs?
Yeah, because you can see the back, but their eyeballs are just.
Oh, because it reflects off of the back of their eye?
Yeah.
All right. Nicholas, question?
Is that why like black is always like if I feel like in the sun's always hotter than like sun?
Yeah, because it's absorbing more of the wavelength. That's why people say you should wear white when it's hot out, because that reflects more of that light and doesn't absorb as much.
But then, like, how do you make that shirt like different colors?
Different dyes. So parts of your shirt right now, parts are pigmented with molecules that reflect pink, and some of your shirt is dyed with molecules that reflect blue. And so the different types of molecules reflect different amounts.
Okay, so why then when you mix colors, you aim to mix green, you don't aim to mix every single color except for green?
What's that?
Like, when you mix colors,
Yeah.
are you technically mixing together like every different color except for green?
I'm not sure if I understand.
Like,
Okay, I think he's trying to say he wants to make green paint.
Yes.
So instead of just using green paint, he uses paint. That's everything except for the color green.
Yeah, because things we call green paint actually reflect green and absorb all the other colors. And if you take different colors and combine them, they absorb various colors and only reflect the color that they make. All right, we gotta move on here. All right, so when light transmits material, it may be transparent, like glass, or some materials are what we call translucent. What is something that's translucent? Caleb?
My shirt.
Okay, kind of. You know, in your bathroom, you may have like frosted glass.
What?
Is that like frosted glass that you can kind of see through, but you can't see perfectly through?
Oh, yeah,
Thank goodness. So, yeah, that is, frosted glass is translucent. Some light passes through, but it gets distorted in a way.
Like some people's like front doors are like that.
Yeah, sometimes.
My shirt.
Your shirt?
Yeah, it's got holes in it.
Well, your shirt, yeah, kind of
Your
has
shirt
holes
is
in it. Yeah. And opaque. The word opaque means that no light passes through it. So this desk is opaque. Okay, your papers are opaque. They don't allow light to pass through them.
Yes, they do.
But if you hold it up, like if you hold it up.
Maybe. Maybe. Slightly translucent. All right, as we talk about light, light can come from two sources. An object can either be luminous or illuminated. What does luminous mean? Something is luminous, Nicholas?
It's shining because something's like reflecting off of it.
No. Yusuf?
It makes like its own light.
It makes its own light. Name something that is luminous.
Light bulb.
A light bulb. The sun. A firefly. Those are luminous.
I want to put like a light bulb.
What is something that is illuminated, Victoria?
Something that like has like a different like something. No, like No, wait, no, I know this one.
Yeah,
Like, can I give you an example?
I guess.
Like, this may be wrong.
Okay.
Like a jack.
A what?
Like a jack-o'-lantern, like because the light is like.
Well,
inside.
in a jack-o'-lantern, what would be luminous in a jack-o'-lantern?
A candle.
The candle, the flame. What would be illuminated? A pumpkin. Illuminated means it's lit by another source. What is your shirt?
That's what I was trying to say.
Illuminated.
Illuminated.
Our shirts are blue. Being illuminated.
Yes, they're being illuminated by light in this room.
Sweet.
Is that why neon is so bright?
Unless you wear a glow-in-the-dark shirt.
Mr. Girls.
Yes.
I wasn't done yet.
What?
Too
Why
bad.
do we tan?
Because we have pigments in our skin that darken as they're exposed to sunlight.
Like cooking.
Sort of. All right. We can do this parts of it. So, when light reflects, what does that mean? Bounces off. We have a couple terms that we use. The incoming light ray that's going to reflect off the surface is called the incident ray. Incoming. If we draw a line where that incoming ray hits the surface, we draw perpendicular to the surface. We call that the normal. And what do we think we call the outgoing ray? No? That light has been reflected. And finally, the law of reflection says the angle of incidence is equal to the angle of reflection.
So it's going to be a 90-degree angle.
Yes.
All the time?
No, not always.
Oh.
Only if it's coming in at 45 degrees.
So if it's coming at 140, it's going to be 40 degrees.
What's that?
You multiply the angle by 25. I don't know.
We'll go over tomorrow.